Hi everyone, it's Sorkin. Today we have a problem when we are given a node in a connected undirected graph and we need to return a deep copy of the graph. So each node in the graph has a value and also it has a list of the neighboring nodes. Okay, let's take this example. Let's say that we have this undirected graph 1, 2, 3, 4, and we need to make a deep copy of it. So what each node represents? Each node has its value and also it has its neighbors. And let's say that we are starting from 4, right? We are given 4, so we are creating a new node 4. And also the next step is we need to create its copy also if it's neighbors 1 and 3. What's the biggest problem here? The biggest problem is that let's say 4 has two neighbors 1 and 3. We created 1 and 3, and also for the 2 we have two neighbors 1 and 3. So we should have for each node, we should have only one node, one copy of that node in the memory. To do that, we are going to keep track of each node that we are creating in a hash table or in a hash map. So we are going to first search for each node, and we are going to save whichever node we are creating. We are going to save that in our hash map. So let's start from the 4, right? So first we are creating 4, and then we are first searching. So we are going to the next one. So none of these exists. So we are going to the next one, which is 3, right? So now we are creating 3. So we are adding 4 and node, right? So we are adding that node, this node that we are created for 4, to our hash table. So we created 4. Now we are going to the next one. 3 does not exist. We are adding 3, also creating a new new node and adding that to our hash table. So but for the 3, the 4 is already exists, right? So we are not creating a new node. So one of its neighbors is 4. We are taking from the hash map, and we are first searching, and we are going to the 2. Again, we are creating 2, and we are adding that to the hash map, and we are adding the node that we created for it. So again, 2 has one neighbor that already created 3. We are taking that from the hash map, and we are recursively calling for the other one for 1. 1 does not exist. We are adding 1 to our hash map, and now for the 1 we have two neighbors 4 and the 2. We are taking 4 and the 2 from the hash map, and now we are backtracking. So now we are backtracking to 1 where we started, to 4. At this point we already have all the nodes. We created all the nodes, and we are returning that node, the root node of that, the node where we started for the deep copy, which is 4 in that case. Also we are returning that value. First thing that we do here, we are creating a hash map where the key is the node value, and the value is the node itself that we are creating, the reference to the node. So in our main method in the clone graph, so what we do, first we are checking the edge case. If the node is equals to null, in that case we are just returning null. The next one is that we are checking that if that node, have we already created that node earlier? If we have created that, then we are just returning that node. If we haven't created yet, then we are cloning that node. So we are creating a new node, and with the value being the value of the node, and we are creating the empty array list, and we are saving that to our map. And the next step is we are recursively adding our neighbors. So for example, in this case, let's say that we are at the last node, taking into account our example that we have seen earlier. Let's say that we are at the node 1, at which point we have already created neighbors 4 and 2, right? They are already in the hash map. So we are recursively calling, and for both of them we are just returning them from the map, the values which we are adding to our neighbors list. And at the end we are just returning the cloned node. So what's the time and space complexity of this solution? The time complexity is that vertices plus edges. So in our case, the nodes, how many nodes we have and how many edges we have. Each node and edge we are visiting once. For the time complexity is determined by the size of our hash map, which is going to be this, which is equals to number of the nodes. So it's O of V. I hope you like my content. If you like it, please hit the like button and subscribe my channel. That's the only way how you can support me. See you next time. Bye.